Hello ladies and gentlemen, and welcome back to another screencast by me, Mr. Stano. This is Regents Earth Science, and here we go. We're moving on to air masses. Probably one of the more important things that we're going to be looking at here within meteorology, because a lot happen around these air masses. And in the next part of our series, we're going to be looking at the interaction of these air masses and all these other variables that we just discussed in these past few screencasts, and how they go to really form our weather. But one of the most important things are our air masses. Air masses are nothing more than a large body of air, a big parcel of air that's characterized by the amount of moisture that it has in it and the temperature of that air mass. So most people think of like a cold or warm air mass, but we also need to look at the humidity within that air mass, or the moisture in there. The air masses come from certain places. That is called their source region, or their origin, where they come from. So when we're looking at a diagram like this of the planet, we can see we have a number of different things going on. We have a cold air mass. Let's use blue. Let's use green. We have a cold air mass up here in Canada. This cold air mass may move in a certain direction. We have another air mass, a warmer air mass down here, and this may also move in a certain direction. We can look at the interaction of these air masses, but as we start looking into these maps, we're going to start looking at where they're actually coming from and the characteristics of that region. So not only do we know at lower latitudes it's warmer, but this air mass is over mostly oceans. So it's also going to be humid. So we have a warm, humid air mass. This one up in Canada, well, it's cold. We know that. It's at a higher latitude. But if you look, this is mostly land. So land is going to be mostly dry compared to the oceans. So we have a cold, dry air mass coming from the north, moving this way, and a warm, humid air mass coming from the south and moving up this way. We have a number of different, we can call these air masses something, but we're going to hold on a second before we do that. So like I said, the air mass has a certain characteristics. The first one we're going to look at is the humidity, or how much moisture is in it. The humidity is going to depend on the source region, where it comes from. That where it comes from is either going to be maritime or continental. Maritime meaning it forms over the ocean. Well, the ocean has a lot of water in it, so that air masses are going to generally be moist. Air masses that come from over land are known as continental. Well, the land for the most part is going to be relatively dry. So continental air masses are dry. Maritime air masses coming from the ocean are going to be moist. The temperature also depends on the source region. Air masses that come from the poles, those high latitudes where it's cold, are going to be known as polar. Air masses that are near the equator or from more lower latitudes are going to be warm, and those will be known as tropical. What's going to happen when we name these air masses, we're going to combine the terms of humidity and temperature. So when we look at this, it's just a little review. We have continental, looks at the moisture content. It's going to be dry. Maritime, moist. Polar, where it's high latitudes, we now look at temperature. That'd be cold. And tropical, warm. And there you have it. So now we can put these together. Continental Arctic, a little bit different. We know that it comes from over land, but Arctic is like way up north. So we're going like at the poles, like Greenland, way northern Canada. Those are going to be Arctic conditions. So we notice how we do this. It's C, lowercase c, capital A, continental Arctic. Whoop, change color there. Continental polar, lowercase c, capital P. Cold, dry air mass coming from central Canada. So the difference between continental polar and continental Arctic is basically how far north it is, or how close to the pole it is. The closer to the pole is going to give it that Arctic A designation. continental tropical. CT, lowercase c, capital T. Warm, dry air mass. We're looking at places like Mexico, southwestern United States. Okay, remember continental coming from land, tropicals, southern, the lower latitudes. Maritime tropical, MT, MT. That's a warm, moist air mass coming from lower latitudes over the water. Best example for the United States, Gulf of Mexico. And our last one, maritime polar, MP, lowercase m, capital P, cold, moist air mass that's going to come from the North Atlantic. So you're looking at places like west of California, near Seattle, those areas right there, Washington, Oregon, those colder waters on the Pacific are going to be a maritime polar, but then also looking at the North Atlantic moving out towards like Maine and those upper areas. Almost got my oceans mixed up. So maritime polar is going to be MP, lowercase m, capital P, cold, moist air coming from oceans in the northern or higher latitudes. I'll leave this to you guys. You're going to name this air mass. I will give you a hint. In your Earth Science reference table, on a certain page, I'll let you figure it out, there is a little chart that has these designations or these little acronyms for the air mass. So you can use that when you're in a bind, but you might want to commit these to memory. It just makes your life a little bit easier, and it makes your taking a test a little bit quicker for you. But like you said, you can always fall back on the Earth Science reference table, and I'll let you figure out what page that one's on. It's not too far off from the other ones we've been using lately. This is just a little diagram right here showing where these air masses coming from. Our continental polar, northern Canada, moving down and through. Maritime polar, remember that's at North Atlantic, moving inwards. Our maritime tropical regions, the southern ocean waters or lower latitude waters. Maritime polar and continental tropical. Nice little diagram to have. If you can get this or copy it down a rough version of it, it would be nice. They do pop up from time to time on tests and quizzes that you may see this, but it's not too bad. If you don't get it, it's not the end of the world, but it's nice to have. And that's it. That's the end of air masses. Hope you enjoyed it. And next time when we meet, we're going to take all these variables, air masses, temperatures, pressures, humidity levels, combine them all to take a look at how it creates our day-to-day weather. So I hope you're looking forward to it. It's definitely a little bit of work, so get prepared. Have a good night. Take it easy.